Hi guys, this is Rinavi George from RVGMATHS and Talents. Welcome to all of you. Let us start the next class, Chapter 1, Real Numbers, Part 2. Okay, already we have started Part 1 and we have studied Fundamental Theorem of Arithmetic. I think all of you have studied that part of the class and you understood that well. Okay. Now we study some applications of this theorem. Okay. Let us say. This is Fundamental Theorem of Arithmetic. That is, every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. That means any composite number can be factorized in a unique way into prime factors. That's the theorem. Let us see some examples based on this theorem. Okay. See the first example. Consider the numbers 4 raised to n where n is a natural number. Check whether there is any value of n for which 4 raised to n ends with the digit 0. That's the question. Let us see the example carefully. See, consider the numbers 4 raised to n. So 4 raised to n are the numbers here and n is a natural number. So can you find examples of these numbers? That is 4 raised to 1, 4 raised to 2, 4 raised to 3, like that it goes. Is it? N is a natural number. That means there are infinite number of natural numbers. So there are infinite numbers here. And they will be in the form of 4 raised to n. 4 raised to 100, 4 raised to 300, like that it goes. Okay. All of you understood that? Okay. Then come to the next point. Check whether there is any value of n for which 4 raised to n ends with the digit 0. That means, can you find any n such that 4 raised to n ends with digit 0? That means numbers ending with digit 0 means it can be 10, okay, then 20, then 30, 40, 50, like that it goes. Is it? 100, okay, 1000, all these numbers are ending with digit 0. Okay, so the question is whether you can find any n such that this 4 raised to n ends with digit 0. Okay, so for that, we suppose 4 raised to n ends with digit 0. We are assuming that there is an n such that this 4 raised to n ends with digit 0. Okay. We have seen that 10 is a number ending with 0. Let us factorize this 10. If you factorize into prime factors, then what will be the factors here? 10 can be written as 2 times 5. Is it? What about 20? That can be written as 2 times 5. Okay. Then what about 30? 2 times 3 times 5. Okay. 100. 100 is 2 times 50. 50 means 2 times 25. That means 5 times 5. Okay. Then you can see in all these cases 2 and 5 are prime factors. Is it? If a number is ending with 10 means its prime factors should include 2 and 5. Is it? That means this 4 raised to n, if it ends with digit 0, then there should be 5 and 2 as prime factors in the factorization of 4 raised to n. Okay, have you understood this? So let us try factorization of 4 raised to n. Okay, let us see. 4 raised to n can be written as, see 4 can be written as 2 square. Then 2 square whole raised to n. That is 2 raised to 2n. See this, 4 raised to n can be factorized as 2 raised to 2n. See, in 2 raised to 2n, you can see 2 is the only prime factor. Is it? 2 is the only prime factor here. That means 5 is not a factor here. And this fundamental theorem of arithmetic says that you can factorize this 4 raised to n in a unique way. So this factorization is unique. That means we cannot find 5 as a prime factor for this 4 raised to n. Since this is unique, is it? So, since 5 is not a factor, you can say that this 4 raised to n cannot be a number ending with 0. Is it? That means this 4 raised to n will never be a number ending with 0. That means we cannot find an n such that 4 raised to n ends with the digit 0. Okay. So, our supposition 4 raised to n ends with digit 0 is wrong. So, there is no natural number n for which 4 raised to n ends with the digit 0. Okay. So, that example is over. Come to the next application. Here, we are studying HCF and LCM. You know, HCF and LCM you have studied in earlier classes. Is it? Already we have studied that. Okay. And just let us revise what is HCF. You just remember what is HCF? HCF means highest common factor. See, H, highest common factor. So, HCF means highest common factor. Highest common factor of two numbers is the largest number that divides each of the given numbers without leaving a remainder. So, let us see example. Let us find HCF of 4 and 6. Two numbers are given, 4 and 6. Okay. Then we are factorizing this. Already we have studied how to find HCF. Is it? So 4 is factorized into 2 times 2. Okay. And 6 can be factorized as 2 times 3. So which are the common factors here? See, 2 is here. 2 is a factor here also. That means 2 is common here. No other number is common here. Is it? No greater number can be found as common factor. So, HCF of 4 and 6 is 2. Okay. You understood this? Highest common factor. So, we are considering the common factors only. Then, its lowest power. Already we studied that. That is 2 here. Okay. The next thing, LCM. What is LCM? That is L. L means least common multiple. That is LCM. LCM means least common multiple. And already we have seen what is LCM. Let us just revise it. We want to find out LCM of 4 and 6. Okay. See, multiples of 4 are 4. We are finding the multiples of 4. 4 is a multiple, 8 is another one, 12 is another one, 16, 20, 24, it goes like this. Okay. Then what about multiples of 6? Just remember multiples of 6. That is 6, 12, 18, then 4 sixes are 24, 5 sixes are 30, 6 sixes are 36, like that it goes. Okay. So we have seen the multiples. Then what is LCM? LCM is the least common multiple. So just find out the common multiples. See here, 12 is a common multiple. That means 12 is a multiple of 4 and at the same time 12 is a multiple of 6 also. Okay. Then what about out 24. 24 is a multiple of 4, and at the same time you can see 24 is also a multiple of 6. But we want the least common multiple. So what is it? So what is LCM? LCM is 12. That is the least common multiple. Okay. See, by factorization we can find LCM. How will you get 4 and 6? Is it? We are given 4 and 6. 4 is 2 times 2. That is 2 square. And 6 is 2 times 3. Okay. So what is LCM? For LCM, we have to take all the prime factors involved in this factorization. So here 2 is here. Then here 3 is. 3 is also here. So take 3 here. Then you take the highest power. Here in the case of 2, it is 2 here. Power is 2, so take 2. And here you can see 3 raised to 1. So 3 raised to 1. So that means LCM is 4 times 3, that is 12. So we got LCM as 12. Okay. So in this way also we can find out LCM. Okay. Then let us consider another example. See, find LCM and HCF of 6 and 20 by prime factorization. Okay, 6 and 20. See here, you can see 6 can be factorized like this, 2 times 3. Okay, and 20 can be factorized. You know how to factorize it? 2 times 2 times 5, is it? Then, if you have any doubt, you can find the factorization like this. 6 can be divided by 2, 2 times 3. Okay. Then 3 is the 1. Then next 20. 20 can be factorized like this. 2 times 10. 10 is divided by 2. That is 5. 5 is divided by 5. Then you can get 5. Then 2 times 5. Okay. That is 2 square 5. Then what is HCF? For HCF, we are finding the common factors only. Here the common factor is, say 2 is here, 2 is here. So 2 is a common factor. Then 3 is here, but 3 is not here. What about 5? 5 is here, but 5 is not here. So 2 is the only common factor here. Okay, HCF of 6 and 20 is 2. Okay, to find LCM, we consider all prime factors involved in this. So 2, 3 and 5 are involved in this prime factorization. Then take the highest powers. For in the case of 2, here you can see 2 is the highest power. So take 2 square. And in the case of 3, 3 raised to 1. Here there is no 3. So 3 raised to 1 is the highest power. So then take 3 raised to 1. Then next 5. 5 raised to 1 is the highest power. So this is 60. Okay. So here we can find that HCF of 6 and 20, that is 2 raised to 1, that is product of the smallest power of each common prime factor in the numbers. So we are taking common prime factors and the smallest power of it. Okay, that is HCF. Then LCM means product of the greatest power of each prime factors. Take each prime factor and take the greatest power. Then you will get it as 60. Okay, I think you understood this. Okay, so here you can see HCF means you take only common factors and least power. Okay, in the case of LCM, you take all prime factors and highest power. That's the difference between HCF and LCM. You just remember this. In the case of HCF, you remember common factors only and least power. Okay. In the case of LCM, we take all prime factors involved. Okay. List out all prime factors and their highest power. That is LCM. Okay. Then next we are finding a relation between these two numbers 6 and 20 and their HCF and LCM. Okay, we have seen that HCF of 6 and 20 is 2 and LCM is 60. Okay, here the numbers are 6 and 20. So if you find the product of these numbers, 6 times 20 is 120. And what is the product of HCF and LCM? 2 times 60, that is also 120. That means you can find a relation here. HCF times LCM will be equal to the product of the numbers 6 and 20. Okay, this is a relation here we can find. Okay. Relation between LCM and HCF. See, we can generalize this. We can generalize this relation, that is for any two positive integers A and B. What is it? HCF of AB times LCM of AB will be equal to A times B. That is product of these numbers A and B. HCF of 6 and 20 times LCM of 6 and 20 will be equal to 6 times 20. The product of HCF of AB and LCM of AB will be equal to the product of the numbers. Okay. Have you understood this? Then come to the next example. Say, find the HCF of 96 and 404 by factorization method. Hence find the LCM. So, you are asked to find HCF of 96 and 404. Then using that, you have to find the LCM. So, how can you find out? Now we have got a relation, is it? LCM and HCF. Product of HCF and LCM will be equal to the product of this number. So first we have to find out the HCF of 96 and 404. So we have to factorize 96. See 96, it is divided by 2, you will get 48. 48 is divided by 2, you will get 24. 24 is divided by 2, you will get 12. 12 is divided by 2, you will get 6. 6 is divided by 2, you will get 3. So the factors are this. Okay. 2 times, how many times? 5 times. 2 times 2 times 2 times 2 times 2 times 3. That is 2 raised to 5 times 3. Then next 404. We are dividing this 404 by 2, then you will get 202. Again 202 is divided by 2, you will get 101. Okay. Then 101 is a prime number. Then 2 times 101. 2 square times 101. Okay. So what is HCF? HCF of 96 and 404. What is it? You have to take only the common factors. So here 96 in the case of 2 is a factor. Here also 2 is a factor. So you take 2. Okay. Then 3 is a factor here, but 3 is not a factor here. That is not common. And 101 is a factor here, but 101 is not a factor here. So you can see 2 is the only common factor. So we list this 2 here. The next thing, you have to take the least power. See here the power is 5. Here the power is 2. So you take the least power. So 2 square. 4 is the common factor, highest common factor. So 4 is the HCF of 96 and 404. So find HCF. That is all. Okay. Next thing, hence find the LCM. So here we have to use the relation. What's the relation? The product of the numbers will be equal to the product of HCF and LCM. Okay. So this is the general relation for any two positive integers a and b. What is it? HCF times LCM equal to a times b. Okay. HCF of 96 and 404 times LCM of 96 and 404 equal to 96 times 404. Okay. You got it? Here HCF of 96 and 404. What is it? You substitute the values here. So HCF of 96 and 404 is 4. 4 times LCM will be equal to 96 times 404. Okay. So LCM of 96 and 404 equal to 96 times 404 divided by 4. Okay. Then you have to find out that value. Okay. So you can simplify like this. 404 can be written as 104. It is divided by 4. Then it is 101. Then you will get 96 times 101. That is equal to, just find out, 101, 96. 6 times 1, 6. 6 zeros, 616. And 9 1 are 9. 9 0, 9 1s are 9. So this is 9696. So that is the LCM of 96 and 404. Have you understood? Next example. Find the HCF and LCM of 6, 72 and 120 using the prime factorization method. We have to find HCF and LCM of 6, 72 and 120 by prime factorization method. So 6 can be factorized like this, 2 times 3. And what about 72? 72 can be factorized. It is divided by 2, you will get 36. 36 is divided by 2, you will get 18. 18 is divided by 2, 9. 2 9s are 18. Then 3 3s are 9. Okay. Okay. Then it is 2 how many times? 3 times. 2 times 2 times 2 times 3 times 3. So that is prime factorization of 72. Okay. That is 2 cube 3 square. Here it is 2 times 3. Here 120. 120 can be factorized like this. 2 times 60. 60 is divided by 2, then 30. It is divided by 2, it is 15. It is divided by 3, you will get 5. Okay. Then here 2 times 2 times 2. Then 3 times 5. So this is 2 cube 3 times 5. Okay. Then we have to find the HCF. What is HCF? In the case of HCF, you find only the common factors. You take common factor. 2 is a common factor here. And 3 is also a common factor here. Okay. So, in the case of HCF, you can list the common factors. 2 times 3. 5 is not there. Then the least power. See the least power. Here it is 1. So that is the least power. 3, that's also 1. So 2 times 3, that is 6 is the HCF. Okay. So you can write HCF is 6. Okay. Then what is LCM? LCM is, you list all the factors involved, 2, 3 and 5. Okay. Then highest powers. See here it is 2 cube. Here also 2 cube. So 2 cube. And what about 3? 3 square. That is the highest power. And 5 raised to 1. Okay. So this is 2 cube, that is 8 times 9 times 5. So that is 8 9s are 72. 72 times 5. What is it? 72 times 5. Okay. 5 2s are 10. 1. 360. So 360 is the LCM. Okay. So you can find LCM as 360. Okay. So HCF times LCM, that is 6 times 360. Okay. That is 2160. So HCF times LCM is 2160. And the product of these three numbers, 6 times 72 times 120 is equal to 51840. You can find that is not equal to 2160. 2160 is not equal to 51840. Product of HCF and LCM is not equal to the product of the numbers. That means in the case of two numbers we have seen a relation, but that relation is not satisfied here, or that relation is not true in the case of three numbers. See here, 6 times 72 times 120 is not equal to HCF of 672 120 times LCM of 672 and 120. That means this relation is not true here. Okay. So the product of three numbers is not equal to product of their HCF and LCM. So we have seen that product of two numbers is equal to the product of their HCF and LCM. But in the case of three numbers, that relation is not true. Okay. So you just remember that. Okay. Then come to some extra questions. Okay. I think all of you love mathematics, and you know mathematics is the queen of all sciences. Okay. So let us together love this mathematics and we can do more and more questions. Okay. So these are some extra questions. Let us do these questions together. Okay. See, find HCF and LCM of 84 and 180. I think all of you have already studied how to find this. Very quickly you can do this. So let us do together it. 84 is divided by 2. You will get 42. 42 is divided by 2. You will get 21. Okay. 21 is divided by 3. You will get 7. So what about prime factorization of 84? 2 times 2 times 3 times 7. I think you have done it very quickly. Okay. That means 2 square times 3 times 7. Okay, you have finished that, is it? Then come to 180. 180 is divided by 2. Then you will get 90. 90 is divided by 2. You will get 45. 45 is divided by 5. Okay. 45 is not an even number. And you know 5 is a factor. So divide it by 5. Then you will get 9. 9 is divided by 3. Then you will get 3. Okay. So the factors are 2 times 2 times 3 times 3 times 5. So you can write 2 square times 3 square times 5. Okay. Now let us find HCF. What about HCF? You list the common factors. See here the common factors are 2 is common, 3 is common, but 7 is not common and 5 is not common. So take 2 and 3 and the least power. Here it is 2 square, here it is 2 square. So you can take 2 square. And here it is 3, here it is 3 square. So least power is 3. 3 raised to 1. Okay. So 2 square times 3, that is 4 times 3, that is 12. So 12 is the HCF. Have you got it? Okay. Then come to the LCM. What about LCM? In the same way you list out all the prime factors involved. You can take all the prime factors included. That means 2, 3, 7 and 5. Okay. So we have written 2, 3, 5 and 7. Then you take the highest powers. Here it is 2 square, here also 2 square. So highest power is 2. Then what about 3? Here 3 square. So highest power is 2. So 3 square. Then 5, here it is 1, here it is 0. Okay. 5 is not here, that means 5 raised to 0. So it is 1. So 5 raised to 1 and 7, here highest power is 1. 7 raised to 1. So this is 4 times, 9 times, 5 times 7. That is 1260. That's the LCM. So we got HCF and LCM of this 84 and 180. Okay, you got it? Then can you verify the relation here? Just let us try. Product of HCF and LCM. What is the product of HCF and LCM? Here we got HCF is 12 and LCM is 1260. So 12 times 1260. Find the product. Be quick. 12 times 1260. And you can see it is 15,120. Okay. And what about the product of the numbers 84 and 180? You can see its product is also 15,120. Okay. So you can say these are equal. So we verified that relation here. Okay. Then another question. Find HCF and LCM of 120 and 144. Okay. We just try. How will you get? Just prime factorize these numbers and find HCF and LCM. Okay. Let us do together. Okay. I think you can do faster than me. Okay. 120 is divided by 2. That is 60. 2 is divided by 2. Then you will get 30. It is divided by 2. You will get 15. 3. Then 5. Okay. So we got the factors. That is 2 times, 2 times, 2 times, 3 times 5. Okay. What about 144? Okay. By the time you have completed, I think. 272. Then divided by 2, 36. Divided by 2. Then it is 18. Divided by 2. You will get 9. Then 3 is a factor. Divided by 3. You will get 3. So you will get, this is 2. How many times? 1, 2, 3, 4. 2 raised to 4. Okay. Times 3, 2 times. 3 square. Okay. Here what we got? Here it is 2 times 3 times 5. Okay. Then what is HCF? HCF means common factors only. 2 is a factor here, 2 is a factor here. And 3 is a factor here, 3 is also a factor here. So 2 times 3, then take the powers. Least power. Here it is 2 raised to 3, here it is 2 raised to 4. So 2 raised to 3. And here it is 3 raised to 1. Here it is 3 square, 3 raised to 1. So 2 cube is 8. 8 times 3, that is 24. 24 is the HCF. Okay. What about LCM? LCM is, I take the factors involved. 2, 3, 5 are the factors. Take the highest powers. That is 2 raised to 4, 3 square and 5 raised to 1. Okay. 2 raised to 4 means 2 square times 2 square. That is 16, 9, 5. 16 times 9 times 5 is 45. So 45. 80. So that is 720. All of you got it? Okay. So LCM is 720 and HCF is 24. Next question is 24 and 72. I think you can do this as homework. 24 and 72. Okay, I think by the time you are very much interested in mathematics, so I think you have done it very fast. Okay, you got it. 24. Just factorize this. 12. 12 is divided by 2. You will get 6, 2, then 3. So it is 2 cube times 3. Okay. 72. It can be divided by 2. You will get 36. 2, then 18, then 2, 9, then 3, then again 3. So you can write this as 2 cube 3 square. So what is HCF here? HCF is see common factors. 2 and 3 are common factors. Then take the least power. In the case of 2 it is 3, and in the case of 3 it is 1. So this is 2 cube is 8, 8 3s are 24. So 24 is the HCF here. Then what is LCM? LCM is list out all the factors 2 and 3, highest powers, that is 3, and here it is 2. So this is 8, 3 square is 9. 8 9s are 72. So here you can see HCF is 24 and LCM is 72. Okay, I think all of you got it. Then let us see the answers. HCF and LCM of 120 and 144. Already we got it is 24 and 720. And in the case of second question, 24 and 72, here you can see HCF is 24 and LCM is 72. Okay, all of you got the answers and you are happy, I think. All of you understood? Okay. Are you happy? Then let us see next question. Find the HCF of 42 and 90 by prime factorization method. Hence find the LCM. Okay. See here, you have to find out HCF of 42 and 90. Then find the LCM. So here you have to use the relation, is it? We have seen a relation. So let us try. 42 is factorized. It is divided by 2. You will get 21. Divided by 3. Then you will get 7. 7 is divided by 7. Then you will get 1. Okay. So you will get 2 times 3 times 7. Okay. Then 90 is divided by 2. You will get 45. It is divided by 3. Then you will get 50. 15 is divided by 3. You will get 5. 5 is divided by 5. You will get 1. Factors are 2 times 3 times 3 times 5. That is 2 times 3 square times 5. So HCF of 42 and 90. You list the common factors only. 2 is common. 3 is common. 7 and 5 are not common factor. So 2 times 3. The least power is 1 here. Okay. So 2 times 3. 6 is the HCF. Then the relation is this. LCM times HCF equal to 42 times 90. Product of the numbers. Okay. So you substitute the values. LCM times 6. 6 is the HCF. Substitute the value here. Then that is equal to 42 times 90. Okay. Then you can write LCM equal to this 42 times 90 divided by 6. Okay. You take this 6 to this side. Then you divide it by 6. Okay. Then 6 and 42, that is 7. Then 7 9s are 63. Then 630 is the answer. 7 times 90 is 630. So LCM is 630 here. Okay. So you got it? So here we use this relation. That means product of the numbers equal to product of the HCF and LCM. Using that relation, we can find LCM here. Okay, you got it? All of you understood this. Okay. So thank you for watching. So let us see in the next class. Okay. Thank you very much.